All right, class. Welcome back to our problem of the week, and looking at problem 27. We're gonna kind of read through it and ask you to think about a couple things, and we'll pause the video, and you'll come back and see if you got it right. So the question is asking is consider the pattern of squares shown below. So I start with 2 squares, and I go to 4, and then it looks like I doubled it again, and I go to 8. So which type of model, linear or exponential, would you use to determine how many squares are in the M pattern? Explain your answer. Now, when they talk about this M pattern, that's just a nice way of saying, well, what's the equation for this function? So, what I want you to do is think about creating a rate table. Pause the video and then come back when you think you've had the proper rate table. And let's move from there to maybe using our stat key. So pause the video. Okay, welcome back. So hopefully the rate table you came up with looks similar to mine in that so for each of the block patterns, we see that we're actually doubling in size. Okay? All right. So the question here is this going to be a straight line or exponential line? Well, easiest way for us to do is just to put it into our equation, all right? And if we put it into our calculator, put the equation into the calculator rather, we're going to come up with the following. Okay, stat, calc, we're going to go to 0, and we're going to look at what this looks like. So yeah, that would make sense to me, that we would have that particular phenomenon. So let's go ahead and put that in our calculator and see what comes back. Okay. So A is 1, B is 2. We raise that to the x power. There's a mistake there. Raise that to the x power. All right. And so that looks like my equation. Okay. And is it linear or is it a straight line? Excuse me. Is it linear, which is a straight line, or is it a curved line? Let's take a look. Okay. So because it is a curved line, we can safely say our solution is not linear. Therefore, let's go ahead and select our exponential as our best choice. Okay, best choice. All right, pause the video and let's consider our next question. Okay, our next question. The data table below shows a medium diameter of grains of sand and the slope of the beach for 9 naturally occurring beaches. All right, so we're being asked to do a linear regression for each set of data and rounding all our values to the nearest thousands. So what might that look like? All right, pause the video and see what you come back with. All right, welcome back. Now, normally I would just have you guys put, point in the middle, point at the end, start at the end, and in the middle. But because of the nature of this problem, I think you're going to get your best results and your most accurate information by putting in all of the points. So that's what I'm in the process of doing now. Just putting in the remaining points and seeing where we are. Okay. So I got all points put in, 1, 2, 3, 4, 5, 6, 7, 8, 9 coordinates. So I'm going to hit the stat button. Okay. It's asked for a linear regression. Okay, so I'm going to hit number 4 for linear. And so I see my linear regression. Let's just get that into our calculator. Okay, welcome back. All right, so we've been asked to round this to the nearest thousands. And so what that means is I'm looking at my tens, my hundreds, my thousands. So I'd have 17.159, and we'll round that up to the x power, to the x, minus 2.10 hundreds thousands. I would round that up to 6. And doing that, let's just check how close my data is. So I go to second, go to second and graph. And let's fix our windows, second windows, where I'm going in increments of, let's go 0.7, and let's go in increments of 0.1. Okay, we don't do that often, but here we go. All right, so let's take a look at this here. 0.7, I got 0.44. Not close at all. Not as close as I'd hope. Okay, let's see if I have, let's check the windows again here. Maybe I'll go 0.01. Hit second. Okay, let's take a look. Now this is a linear regression, which means that these numbers are going to kind of be not dead on, but somewhat in the middle. So 0.7, okay, 0.9. It's an interesting little mishmash of what to expect. Okay, close to 0.7, a little more. Go 22. 22 is little more than 0.82, but the big picture here is we're doing, and it's the biggest point, we're doing an nearest thousands. We're doing an estimate of possibilities. So although they're not spot on, they're close enough for us to feel comfortable that the data represents a line in between the data points. Okay, so I hope that was helpful.